Hello, in today's lesson, we're going to look at how to make a good number line. And we also kind of review how to answer questions with complete sentences with units included. So let's look at the first objective. Providing answers in sentence form, including units in all responses. With the following paragraph, a housing committee is reviewing the cost of a two-bedroom apartment in Santa Monica, California. Data on average rent can be found on the website rentcafe.com and is summarized in the table below, where the rent is in dollar per month. Okay, let's answer the question using the table. Now note that I filled in the answers for the questions already. The reason I'm doing that because I want to limit the length of the video under 20 minutes. So I'm going to explain each one of those responses. So let's do the first one. Interpret the line for May 2015. Okay, let's look at May 2015. Now the table here is average rent for that month. So therefore the unit here is in dollar. Okay, so and that's a cost for a two-bedroom apartment in Santa Monica, California. So to interpret that, I could say the average rent for a two-bedroom apartment in Santa Monica was $4,386 in May 2015. That's it. I just write the line down in a complete sentence. Number two, which month and year has the highest rent? And what was the rent? Okay, let's do that. The highest number here is 4,674, and that corresponding to May 2016. So let's answer the question. So I say May 2016 had the highest average rent, and it was 4,674. Now note that I look at the table when I write my, I'm writing my sentence here. Let's look for the next one. The next one says, between January 2015, okay, let me highlight January 2015, and May 2015, okay, did the average rent for a two-bedroom apartment increase or decrease? Okay, let's look at it. Now notice that there's an increase right here. It's going up here, right? Going up from January 2015 to May. And how much did this increase? Well, let's calculate. Let's subtract it. So I would have 4,386 minus 4,125. When you subtract it, you can use a calculator here. Then you'll get a 261, not 2,000. So that's how much you increase from January to May. Okay, so now let's answer the question. So the average rent for a two-bedroom apartment in Santa Monica, California is increased by $261 from January 2015 to May 2015. Okay, let's look at question number 4. Between May 2016 and September 2016, okay, May and September of 2016, that's a two. I want to highlight my numbers. Did the average rent for the two-bedroom apartment increase or decrease? Again, I noticed that the number getting smaller here from 4,674 go down to 4,152. So there's a decrease right here. So decrease. So how much it decreased? Again, I do the same thing. I'll just subtract them. So we'll say 4,674 minus 4,152. You subtract them, and you would get 522. Okay. So now let's answer the question. So I said the average rent between May 2016 and September 2016, there was decreased by amount of $522. Okay, so this completes our interpretation of data points. I'll suggest you maybe do a little bit more homework from the IR reviews and to in practice of writing out complete sentences. I also upload some extra practice handout under unit review on Canvas, so you have time to take a look at those files as well. Let's look at objective 2. Now here we're gonna review how to make a good number line. In good practice for a number line is always make a number line using the good spacing. Notice that good increment, good spacing, and make sure it doesn't show any unnecessary part of the number line. So let's do this example here. So below are 4 different proposed number line graphs for average money rent for a 2-bedroom apartment between January 2015 and May 2016, the period when the average money rent was increasing. Now for those data set on page 1, I make a copy here. Look at each graph and discuss whether the graph represents the data well and whether it's a good scaling techniques. If the number line is not good representation or does not use good scaling techniques, explain why. As always, use full sentence in your discussion. Okay, let's do one plot at a time. First plot. If the number line is from 0 to 5,000, okay, let's look at my rent. My rent is from January 2015 to May 2016. So May 2016. So those are the amount here that I intended to plot. So notice that the amount is always about from 4,000 to 5,000. So if I would plot them, meaning that my data point will be all land on this area here. That means there's a bunch of extra space right here that we will not use at all. Notice that this will be unused. So this part here is unnecessary. So since the minimum rent is 4,125, there's no need to begin your graph at the 0. So the graph here does not use scaling and doesn't represent the data well. Okay, let's look at plot 2. In plot 2 here, I noticed that the numbers are, from 4,125 to 5,000. Okay, looks the number about right, but let's check the increment. Okay, so to get from the first number to the next number, I need to add $216. Okay, and then from the 4,386 to 4,463 is an increment of 77. Now notice that it's not using equal increment here. So this number line is incorrect. It used incorrect increment. The increment here is not equal each time. So when you draw a number line, it's important that each time, each tick mark, from one tick mark to the next, use equal increment. So this is a really bad number line. All right. It uses of scaling is incorrect. Okay, let's look at plot 3. Let me put the data down here so we can see them. Okay. In plot 3 here, I noticed that my graph from 0 to 500. Wait a minute, my rent is always from 4,000 to 5,000 in that period here, but 0 to 500 is totally outside the range of my data point. So if I would plot them, none of my data will show on the plot here. So therefore, this is a bad graph as well. Okay? The graph is outside the range of the data set. If I would graph them, none of the value from the data set can be shown on the graph. So therefore, this is a really bad one as well. Let's look at number 4. Plot number 4, it looks like the value is about 4,100 to 4,700. Okay, it does include the maximum minimum value. So notice that minimum and the maximum value. And let's check the increment. Now the increment here from 1 to the next, this is what 100, 4,100, increments of 100. And the next is also increment of 100. Now the every time is increment is 100 increment. And the spacing here is equal spacing as well. So this is a really good graph for this set of data. Right? So this is the best of the 4 here. It uses scaling, and all the data points can be plotted on the graph and can show easily. Right, now let's look at another example. Suppose you are working with a data set representing the average monthly temperature for a certain city over 6 months of a year. The average temperature is given in degree Fahrenheit. Okay, so we're going to learn how to draw a number line to represent this data set. So let's work through how to set up a number line for the data set. How? Now, number 1, part 1. review your data set. Identify the smallest and the largest value to be plotted. Okay, for this data set here, the smallest value is 27 and the largest value is 84. So 27, 84. Now, select a range of value for the number line that will include both the smallest and the largest. Okay, so, and 3, which is step 2 here, step 3, the spacing between each of the lines should be the same. Again, spacing should be the same, equal spacing. And change in value between the lines should be the same as well. Use equal increment. Choose a difference between tick marks that will consistent. Again, difference between tick marks have to be consistent and cover the entire data set. Meaning that I want to make sure my data set is included and shown, in the middle, the majority part of the data. Number 4, after setting up your number line, plot the value from the data set. Remember, the scaling of a number line comes before plotting the value. Label the graph. Okay, so let's plot this data, and but before we plot them, let's do step 2. We're going to choose a range of value. Explain which range of value here is good for this data set. Okay. Now, here for each of the following, determine whether the range will work for the data set or not. Explain your response. Okay, so again, remember my minimum here is 27, my smallest value for the data set. My maximum is 84. So let's look at the first one. At a range of 20 to 90, does it include both my minimum and maximum? Yeah, it does. 20 is a little bit under 27, 90 is a little bit over 84. So yes, it does show my data well, and this is a good use of a good one. So I'll say yes. Right, there's a potential good one. Let's see which one's the best here. So 20 to 80. Now 20 to 80, notice that if I will use this range here, 84 will not shown on the graph. So this is not a good one. It doesn't show the maximum. 0 to 120. Wait a minute here. My smallest 27. There's no need to begin at 0 here. So it shows some unnecessary part of the data line. Also, the maximum is 84. It's no need to show anything more than 90 here, but it's up to 120. So therefore, this is not a good one. Okay, negative 100 to 100. Again, the smallest value here is 27. There's no need to show any negative number or any number below 20. Or any value here more than 90. So it shows some unnecessary parts here. So therefore, 20 to 90 is the best of the here, and this is the correct one as well. So we're going to use this one to plot a number line. Okay, so which is the next one. Let's set up the number line. Okay, so here, set up the number line. How many units should the line spacing? Meaning the differences between the tick marks on the number line represent. After setting up the number line, let's plot them. So first of all, I want to use a really good spacing here. So let's draw a number line to represent what I wanted. So I want it from 20 to 90. So let's grab them. So draw a line first. I'm going to start with drawing a line. Okay, I'm on a line that's kind of cover majority of the blank space here. And 20, again, remember my range from 20 to 90. So I can start with 20. Again, I can do an increment of 10, 20, 30, 40, 50, 60, 70, 80, and 90. I could do that. I can also do an increment of 5, 20, 25, 30, 35. Let's start with the 10 first. If we need it, we can cut down further. Oh, let me draw the number line a little better. It looks a little slanted. I recommend for draw a number line and use a ruler, or maybe use your steel 90 to draw a straight line. Here I'm using a sketching tool here. Okay, I think this looks better. Okay, so I'm gonna start with 20. I'm gonna do an increment of 10 first. Right, so 20, 30, 40, 50, 60, 70, 80. Now that I can extend my number line a little bit longer to 90. Oh, let me extend and draw a little straight line here. I can extend a little bit, make it 90. Now here, once I extend, I know that I extend my number line to make a big range here. It's shown big number. And if I like, I can even make it even more accurate by adding a tick mark in the middle. So this one over here, between 20 and 30, that'll be 25. Here will be 35. Here will be 45. Here will be 55. Here will be 65, 75, 85. Note that even though I add a tick mark between 20 and 30 with 25 here, I don't have to label each tick mark here. Actually, if you label all the tick mark here, it might be a little confusing. So you can just leave it like that. Okay, so I'm using the equal spacing here approximately. Again, it's a little hard to draw in a computer here. So I would suggest you use your ruler, make sure to draw, and hopefully your graph will look much better than mine. Okay, so let's plot my values. And the values for from the previous page. Okay, let me put the value here. Value are temperature. So for January, the temperature is 27. So 27 and then 125, so 27. That's January. I can write it up here if I like. For March is 44. 44 should be under 45. So it's 44. And then for May is 71. For July is 84. Notice that increasing here. And then in September, go down to 68. And then in November is 34. Okay, so now that all my data point can be easy to read here. So this is a good number line, right? Let's look at another example. A student is taking a biology class, a math class, and a history class. Each class has 5 exams. The table below gives the students exam score in each of the 3 classes. Okay, now notice I labeled exams biology as 1, math data is 2, English is 3. So just easy to talk about here. So data set 1, data set 2, data set 3. Now let's look at each data set. How do they differ? How compare the range of the values? Okay, so notice that all the values for all 3 classes are between 0 and 100. That those are exam scores, which exam scores from 0 to 100. Although they all fall into 0 to 100, they have different consistency. Note that for biology, the range of the values are between 45 and 89. That's the range. For math, it's all between 80 and 90, which is 82 to 87, the max. For English, it's very inconsistent here. The score is as low as 0 and as high as 95. So the range are all different for 3 classes. Next one. Let's plot the biology exam data on the following number line. Okay, biology data is 45 to 89. And we can plot them. So, biology, first one is 45. Have here, 45. Exam 2 is 57. Exam 3 is 70. Exam 4 is 73. And exam 5 is 89. Note that this number line shows the data really well. And there's no unnecessary part of the data, the plot here, or the number line here. Right? So you use good scaling as well. Notice that the increment is equal, the spacing is equal. So this is a really good number line for this data set. Okay, what happened if you try to plot the exams, math exam data? Okay, the math exam data are, let's look at math exam data. The range for math exam data are between from 80 to 87, right? And plot here the range, 80 to 87. That means if I would plot them, all my value would be within here, in the 80s. Could be all here. So there's a lot of unused space here. Notice 40 to 80 here will be extra space that will be unused if we would plot them, which is unnecessary. So although this same number line works well for the biology class, but it doesn't work well for the math class. So a a plot that work well for one data, not necessarily going to work well for another data set. Okay, let's look at the next one. What happens if you try to plot the English exam data on the same number line? Again, the English data exam scores are between 0 and 95. And so that means the value, let's say exam 1 is 0, is not going to show on the data. So this graph here is not a good plot for English exam scores either. Because if I plot them, exam 1, 2, and 5 are outside the range of the number line. Okay, so it's pretty bad. Now, let's draw a number line plot for math exam data. This is for math. Notice that I write exam score on the left here already. Choose a scaling system that will work well for the given math exam data set. Okay, so I notice my range is from 80 to 87. So I do not need anything else less than 80. My values, so let's draw them. So my minimum should be 80. I could do 80, or you can do, a little bit smaller than 80, but I can just do 80 because the range is 80 to 87. And pick a beginning point. All right, let's do it. So I'm gonna draw. So let's say this is my 80. Now plan ahead here. So how many data points do I need here? I can plot them. I could say 80. I want to make sure equals scaling here and use of space as well. So make sure you don't draw them too much out. So I could say maybe I draw the maximum here. I'm going to draw maybe 80A over here and plan on here, maximum here. And I can divide the whole space here into half. I'm eyeballing here. I would say in your paper, you could use a ruler. I can draw the first half into half again. I can draw this, let me draw a little better. I'm eyeballing the distance here. And the top half again. Half is a good way to get some data point. Plotting, scaling here. Looks about right. Okay, so and my maximum is, only 87. So I could increment by 80 by 2s. So it should be 82, 84, 86, 88. Now note that my increment is by 2. Okay, so let's plot my data now. First score is 82, so it's right here. And then I have an 80. Then I have an 85. And I have an 87. And I have an 85 again. Okay. Notice that there's no unnecessary space on my number line here. Okay, so this is my math exam score. So I can even label my my line here. I say this is a math exam scores. Okay. Let's draw another number line for English exam data. Now, notice that for English is from 0 to 95. So the number line that I did for math not gonna work for English. So I need to do a different one. Okay, let's think about it. 0 to 95, meaning that I might have a big range here. Maybe I would have begin at 0, have to be begin at 0. And now I need to decide how much I need to increase. 0. If I increase by 5, might be a little too much, but because I need to get all the way up to 100, so maybe increment by 10. So I will pick an increment of 10. And it's important here you use a pencil. So in case you want to change a number line, erase them, you do it again. So 20, 30, 40, 50, okay, 60, 70, 80, 90, 100. Okay, looks like I used the whole entire number line here. Next thing is I'm going to plot them. So first one is 0. And then I have a 26, a little bit more than 25. Then I have an 85. I have a 56 next, a little bit more than 55. I have a 95. Again, I hope that your number line look better than mine here. I feel like this the spacing here, some of them is a little bigger than the other. Although 95 should be halfway in between, so it should be somewhere here. This should be 95, okay? So that is my English exam data. English exam scores. Right. I kind of make a title for my graph. All right, this completes our lesson. Thank you for watching the video. I'll see you next time.